Welcome. In April of 2021, the sun was quite active. So let's see what was happening to solar cycle 25 during that month. So what are we going to cover today? We're going to look at see how solar cycle 25 has progressed so far in terms of the number of sunspot regions, flares, coronal mass ejections, geomagnetic storms, the 10.7 centimeter radio flux, and total solar irradiance. We've got some movies, both from HMI and AIA on the Solar Dynamics Observatory, and also the Soho-Lascaux coronagraph images. Well, let's take a look at the sunspot averages for the month of April. The average sunspot number for the month was 24.5, which is a 40% increase over March. There were only 6 spotless days in the month. 9 active regions were numbered by NOAA. Now, these are not regions that just produced a sunspot, but they were big enough and lasted long enough that NOAA numbered them. So the number of regions that I take a look at is a much larger number. Predicted sunspot number from the Royal Observatory of Belgium will be 40 to 80 by the end of this year. So that would be a near doubling over the amount of solar activity that we have currently. Along with everything else, the number of sunspot regions is increasing. We have had 74 new cycle sunspot regions so far in 2021. That compares with 1 in 2019 and 13 in 2020 by the 1st of May. In fact, it took until the 26th of October in 2020 to reach the number of 74. So you can see that solar activity is rapidly increasing. We could take a look at the percentage of regions that are from solar cycle 25 compared to those that are still associated with solar cycle 24. You may have noticed from the previous plot there were no solar cycle 24 regions in April. And so the percentage of solar cycle 25 regions is steadily increasing, and I suspect that we'll get fewer and fewer solar cycle 24 regions as we go along. This is a plot of the number of flares as a function of time. It's color coded. Blue is solar cycle 24 C flares. Those are the smallest relevant flares. The reddish orange is solar cycle 25 C flares. Green is solar cycle 25 M flares. You can see we had the third M flare of this cycle in April. And then also X flares will be indicated by a purple color. However, we haven't had any X flares as yet. I expect some relatively soon, certainly by the end of the year. But April was the second most productive flare month of the cycle so far, dwarfed only by November of 2020. Let's take a look at that M flare on the 19th of April 2021. It was from active region 2816. The flare started about 2319. Now that is a little bit difficult to pin down because there were lots of activity in the region just prior to that, and it's hard to say which of those changes were the ones that actually initiated the flare. The flare peaked at M1.1 level at 2342. M1.1 is 11 times stronger than a C1 flare. The flare ended at about 120 UT on the 20th of April, but there again it's hard to really pin down when the flare ends because there's always still hot material and some reconfiguration going on, sometimes hours later. I have 3 movies for you. The first is a slightly different one. It's the 1700 angstrom movie from AIA, and that will show you the location of this flare with respect to the sunspots. You'll be able to see the plage region and the sunspots in the movie, and then there'll be a slight flash of brightness between some of the sunspots, and that was the location of the flare. Then we're going to show you the 171 angstrom coronal loop channel, which gives you some idea of the dynamics. And you'll also see an explosive wave move out from the flare site when the flare first goes off. This is called a Morton wave. Lastly, we're going to take a look at the flare itself in the AIA 94 angstrom channel, which is about 6 million degrees Kelvin. Next, we'll take a look at something completely different. I've not discussed the 10.7 centimeter solar radio flux before, but this is a plot of it since solar minimum in December of 2019, and it's a measure of generally solar activity. You can see that it's been the background has been increasing significantly since that solar minimum, and you can see those three major bursts of activity in October, November, and December as those spikes around about 2238. The number along the bottom is Carrington rotation number, which you can convert to date if you want to look it up. Next, we'll turn to geomagnetic storms. There were 6 storms in the month of April, the same as in March. They were all low-level storms and caused no major disruptions. However, the M1 flare did disrupt some radio communications in parts of the world, those facing the sun when the flare went off. Another thing I haven't talked much about in the past is total solar radiance. This is a plot again from solar minimum to the present. That minimum back in December of 2019 is already 0.15 watts per meter squared, higher than the last solar minimum. So we've started from a higher level of activity than we had back then. Now, since then, we've had about another 0.15 degrees watts per meter squared increase since our recent solar minimum. You can see the slope of the plot here. One of the interesting things here are these large dips. That's when you get large sunspots crossing the sun. So the sun is temporarily dimmed as a result of large spots being on the disk, which is what you would expect. But the subsequent solar activity more than makes up for that overall. Normally, I give the coronal mass ejections the last place in the set of movies that I show, but I thought I'd put it in first place this time. And just to give you some orientation about what you're seeing in these chronograph movies, take a look at this. We have the circle in the middle here is the actual sun. This would be a helium-2 304 image. The red area around that is the C2 instrument chronograph on the SOHO spacecraft, and the blue area is the C3 chronograph on the same spacecraft. That black diagonal, which can appear in the bottom left or the top right, is the support grid for the chronograph occulting disk. The two bright objects that you'll see going across the disk are Mercury and Venus, Venus being the brighter of the two. The little bright dots that go from left to right across the screen are stars. In fact, you may be able to identify some of the constellations at certain times of year. And you'll see little streaks that appear only in single frames every now and then. Those are cosmic rays hitting the focal plane detector of the instrument. So with that orientation, let's take a look at the movie for the month of April. Next, we're going to take a look at the exciting topic of solar eruptions. For that, we use the Solar Dynamics Observatory AIA helium-2 304 channel. This corresponds to a temperature of about 50,000 degrees, and what we're looking for here is cool material, or at least relatively cool material, suspended in the coronal fields, magnetic fields. And these are particularly associated with coronal mass ejections. When they lift off, that produces a coronal mass ejection. Flares can also do the same thing. So where there are magnetic fields, there are magnetic loops, just like you see with iron filings around a magnet. And that's exactly what you see when you look at this particular line from the SDO AIA instrument at 171 angstroms. The temperature here is about 600,000 degrees, so it's the cool part of the corona. Watch for changes in the brightness of loops and interconnections between various sunspots and also between active regions themselves. Note even the quiet areas of the sun are fairly dynamic. They're changing also, but not quite necessarily so spectacularly as is occurring in the bright active regions. Next, we'll move a little higher in temperature to the temperature of active regions in the solar corona, and that's about 2.5 million degrees Kelvin. This is using the SDO-AIA line at 335 angstroms. These bright areas are isolated. These are the magnetic active regions associated generally with sunspots, although you'll notice there's more bright areas than there are actual sunspots in the original Sunspot movie, because some of these regions, although they're magnetically active and also produce warming in the corona, aren't big enough or strong enough to produce a sunspot. Last, but by no means least, we're going to take a look at some flares using the SDO-AIA 94 angstrom channel. The temperature here is about 6 million degrees Kelvin, and any bright flashes here are flares of some sort, either B flares, the brighter ones are going to be C flares, and the brightest one you'll see here is the M flare on the 19th of April. So what can we conclude from all of this? The solar cycle 25 is well underway and accelerating. We can tell it's accelerating by the increase in sunspot activity, the increase in flares. We've got another big flare, for example, and the increasing number of coronal mass ejections. We're expecting another burst of activity in the next 2 to 4 months, equivalent to those back in November of last year. So this is an exciting time to be observing the sun, and I hope you take advantage of all the data that's available online. So stay safe, stay well, and until next time, goodbye.